So in this video, we're going to introduce trigonometry, and that's going to start with how to label a triangle and the three basic trigonometric ratios. So first of all, trigonometry is going to start by only considering a right angle triangle. So there's one in the diagram in front of you. So if we have a triangle such as this blue one here, okay, the first thing to understand is we need to label this correctly every time we start a trigonometry question. So the diagonal side is always known as the hypotenuse, okay? So we often just refer to it as H, and it is diagonal from the right angle, and it will never touch that right angle. So always identify the right angle and find the side that doesn't touch it. That's the hypotenuse. Now, when working with trigonometry, we are always looking at a specific angle, okay? And in the example in front of us, that angle is right here, and it's labeled with a theta, the Greek symbol theta, okay? And that is important to recognize that. Now, so the opposite and the adjacent are the other two sides, but they are dependent on what angle we're focusing on. So if we are focusing on this angle in the bottom left, then the opposite is the one that is opposite that angle. We refer to it as O, and the adjacent just means next to, okay? So A, the adjacent, is always next to the angle. So every time we see a triangle, we need to label what is H, O, and A. So let's have a quick think about a couple of triangles. Let me draw a few examples for you. Forgive my poor pictures. So here is a diagram, and we have a right angle given, and we have an angle given, in this case theta. So if I want to label up my triangle, I need to make sure we do it correctly. So have a think, what is the hypotenuse? Of course, it is the one that does not touch the right angle. It's the diagonal line. So that side there is H. Which one of these is going to be the adjacent? Well, adjacent means next to. So it's next to the angle. So that leaves O, the opposite. It's opposite the angle on that far side. Right, let's do one more. So let's think about this particular right angle triangle. Let's give it an actual numerical value this time. So there we go. That's the situation. The right angle is there. Let's start by thinking about the opposite. What do you think the opposite is? Of course, it is opposite the angle. It is that one there. The adjacent is next to the angle, so it's there. And so the hypotenuse, the diagonal line that doesn't touch the right angle, is there. So this is really important every time we start. Now, once we've done that, we are now ready to define some trigonometric functions, okay? So if we take a triangle, any triangle at all, and we wanted to define the first ratio, that's just going to be the number that is the opposite divided by the hypotenuse, okay? O divided by H. Now that's known as the sine ratio. The cosine ratio is the adjacent divided by the hypotenuse, and the tangent ratio, tan, is the opposite divided by the adjacent. So what exactly does this mean? Well, let's just think about a nice simple right angle triangle, and we'll draw the most simple we can think of here. Look, okay, so here it is. Let's zoom in on it and let's put in some measurements. Okay, this is a true triangle, and let's have an angle there. Look, I don't know what that angle is, no idea. Perhaps we can find it later. But if I'm considering this particular triangle and I want to know what the sine ratio is for this triangle, it's going to be the opposite divided by hypotenuse. So before we go any further, let's just label this up. So there's my opposite, the 3. There's my adjacent, that 4. And the hypotenuse is going to be 5. Now, the angle, I don't know what it is, no idea, but it doesn't matter. I just want to find the sine ratio of the angle. Well, that's going to be O divided by H. So the sine of theta in this particular case is going to be 3 divided by 5. And you could write that as 3/5 or 0.6, it doesn't matter. The cosine ratio for that particular angle in this particular triangle is the adjacent divided by the hypotenuse. Well, the adjacent is 4. the hypotenuse is 5. So we've got 4 over 5 there, look. And of course, we could write both of these as decimals. It doesn't matter. We don't have to use fractions in any way. The 4 and the 5 are not irrelevant as such, but I want you to understand that we could easily have it's the numerical value that is correct. Right, and the tangent ratio for this one, well, that is opposite over adjacent, so that's going to be 3 divided by 4. We could write 3/4, or we could write 0.75. Okay, now, important point when we understand what this is all about is the scale of the triangle doesn't matter. So if I was to enlarge this triangle, let's just make an enlarged version of the triangle, and I times each side by a scale factor of 2. So for example, I would have 8, 6, and 10. Well, and this is the angle again. That angle will be the same. The theta hasn't changed, okay? It's a similar triangle, which means the triangle's proportions have stayed the same. And look, if I was to find the sine of the angle in this case, that's opposite over hypotenuse, it's going to be 6 over 10. Well, that's 0.6. The point of me saying this is it doesn't matter at all what the size of the triangle is. The only thing that matters is the proportions of the triangle. So if these two triangles are similar, then not just the sine ratio, but the cosine and tangent ratios, they're going to be the same for both triangles. And in essence, what's really happening here, we can use this. Your calculator has these sine ratios and cosine ratios and tangent ratios stored inside it, and we can pull them out to help us to find different angles. Okay, I hope that makes you understand how to label a triangle and what the 3 different relationships are. I will just finish by simplifying this for you. Often, you may have heard this before, SOHCAHTOA. And this comes from the relationships, the sine theta being the opposite over the hypotenuse, the cosine of an angle being the adjacent over the hypotenuse, and the tangent of the angle equal to the opposite over the adjacent. And you can see that these 3 ratios match the word SOHCAHTOA. And even more useful for us would be to think of them as magic triangles, SOH, CAH, TOA. Now, the reason for that is that we know that the sine of an angle is the opposite over hypotenuse. But if your calculator has the sine of the angle stored in it, then, and maybe we have, say, the hypotenuse, we could find the opposite. We could use these triangles to help us to find missing sides, because the sine ratio inside the triangles or the cosine or the tan are all stored there, and that's what we'll be looking at in the next video.